Hey everybody, welcome back. Happy Thursday. It's Thursday. Oh my goodness, my days are bleeding together. Today we are going to talk about composite figures, and more specifically, how do we find the surface area and the volume of a composite figure. So go ahead and pause this video and get out your textbook or go online and go to page 685, which is the Inquiry Lab in Chapter 8, okay? Page 685. So hopefully you have that out. So now we're going to talk about a composite figure. Now remember, a composite figure is when we have two shapes on top of each other. So for instance, this is a composite figure, and it's very similar to what you see in your book on page 685, the building on top of a building. We can figure out what are the volumes of these two. We know what type of shapes these two are. These two three-dimensional shapes are, of course, if you don't, I'm going to give you a second to say it. If you said they're rectangular prisms, you are correct. Two rectangular prisms on top of each other. So, if you look down at the hands-on activity on page 685, number 1 says, model the top and bottom rectangular prisms using cubes. Well, if you have some cubes, feel free. If not, you can see that it's got your cubes that are 1 unit each. Okay, in this case, they're centimeter cubes. So, we can count the cubes to find the dimensions. So, they have on the bottom, they already have 6 and 1 filled in, right? Well, what would be the height of that? We look at there's 1, 2, so we see that there's a height of 2. And then what would the volume be? Well, if we remember our volume formula for a rectangular prism, it's length times width times height. So, what do we get? 6 times 1 times 2 is 12 centimeters squared. Okay. You got 12 centimeters squared. What about the top then? Well, go ahead and pause this video if you need to and fill in that first row. Or excuse me, the second row. So we got 4, 1, 2. Hopefully, you have this. 4, 1, and 2, right? Yes. So when we look at that, that is our dimensions. So let's multiply across. 4 times 1 times 2 is, of course, 8. Exactly. And so we should have our chart at the bottom for step 3 filled in like so. The question then comes to us, what do we do with those two volumes? Would we multiply them or would we add them? And you're right, they are an addition. We would add these two volumes together to get the volume of our composite figure. So, of course, 12 plus 8 is 20 centimeters cubed. Yes, that is our volume for today. And I'm going to adjust because there we go. Let's see, this is... Make sure the light doesn't become too dark and foreboding. Alright, hopefully that helps with the glare. Okay, so that is page 685. We find the volume of the two separate figures, and then we add those together. Okay, hopefully not too complicated for us. So let's go ahead and go on to the next page, which is on page 686, okay? So, let's see. We've got a little house, don't we, on page 685. And it says, Mr. Wendell's class made a model of a house. The model was composed of a rectangular prism and a triangular prism. Determine the volume and surface area of the model house. So, we have both need to find both the volume and the surface area. Okay, so step 1, we looked at a hands-on activity. We use a rectangular prism to model the bottom of the house. Use a triangular prism to model the top of the house. Excuse me. Excuse me. Let's see. So we complete the tables below using the models from step 1. And so we see that on step the first step, we have a length of 4, a width of 3, and a height, length of 4, width of 3, and a height of 3. Okay? Our next one, we have also a length of 4, a base of 3, and a height of 2. So this should be your step 2 then. Okay, that should be your step 2. So we use the information for the table of models to find the total volume of the model house. Okay, so how do we find the volume of the model house? Well, we do the volume of the rectangular prism, which is, of course, length times width times height. Rectangular prism, 4 times 3 is 12, times 3 is 36. 36. And we're going to add that to the volume of the triangular prism, which is big base times height. So that would be 1/2 4 times 3, which would be 6, times 2, which is 12. So we should end up at step 3 with this, 36 plus 12, which is, of course, what? And you are right where you say it's 48 centimeters cubed. Okay, 48 centimeters cubed. Now, here comes the kicker. When we have to find the surface area of the two figures, but we have to also figure out what is the part that we don't need to use, okay? Go ahead and look down at step 4 with me. Skip that first blank, skip that second blank, and go to the third blank where it says areas where prisms connect, okay? So let's say I have 2 rectangular prisms and I put them on. This is technically a composite figure, right? I don't count the surface area where these two come together, okay? I don't count this area in my surface area. So that means I have to subtract a section where they are touching. I subtract the part of the surface where they're touching, which is nice for us because it is basically just the base, okay? We just have to find the area of the base, and we subtract that from the surface areas. So in this scenario, we do the our surface area formula, and you can go ahead and get out your surface area formula for rectangular and triangular prisms. The surface area for step 4 for the rectangular prism should be 66. The surface area of the triangular prism should be 38. And then when we look up, how do we find out what is the surface area of the areas where they connect? Well, it's the top of the rectangular prism. And so that would be 4 times 3, right? Which would be 12. Well, it's not, because there's one other spot we didn't do. We did this part, but we also need to find for this part because they connect together, okay? So, but the nice thing is that they're the same number, right? So we have 12 plus 12, so we're going to subtract 24. We're going to subtract 24, okay? So we do this, and we end up with 80 centimeters squared, and we find that the cubic centimeters, the volume is 48, and the surface area is 80. Okay? So hopefully that's making a little bit of sense. And what we can look over is that we can see at the over on page 687. Let me zoom just a little bit out. There we go. So I can see that. We've got a couple of different problems on page 687. And so Here's what I want you to do for this morning and today, if you're looking at this in the afternoon. I want to make sure you guys are actually logging on and doing this. So there's two parts to this, okay? I want you to do what I want you to do as your assignment. Sorry, I'm gathering my thoughts. Here's your assignment, technically. This is just like a participation assignment. You need to comment on this video with a hi Mr. Heppy, good morning, good afternoon, happy Thursday, just so I know that you saw the video. And then, here's a little bonus that you can do that I'll put onto your homework grade. Pick either 1, 2, 3, or 4, and pick 2 of those problems to send to me today, either by taking a picture or sending it to me via email. Okay? So here's your 2 things. Number 1, everybody needs to comment at the bottom of this video with something to let me know that you saw this. Number 2, after that, you're going to, if you want to, pick 2 of the problems on page 687 to do, and go ahead and send it to me. Okay? If you have questions, make sure you're asking them, all right? And I'm available, guys. If, let's say you want to get like some step-by-step instruction, we can set up where we do a little Zoom meeting so you can actually see my responses live, okay? So I hope you guys have a great Thursday, and make sure you're following those assignments. I'll see you all soon. Bye-bye.